Okay, so in this one, what we have then is the pre-prepared, we're not going to do the mechanism this time, but what we have is the pre-prepared molecule of 2-hydroxy propanitrile, which we prepared by nucleophilic addition in the previous couple of clips. And what we need to do is draw this correctly in a three-dimensional sense by using the three-dimensional notation, using the wedges and then the dotty dashed lines. So we'll have the hydroxide, hydroxyl group, should I say, attached to that one there, and then we'll have the nitrile group coming towards us in that tetrahedral fashion. Okay, so each of these bond angles 109 degrees, etc., etc., analogous to methane. So as we've established, this central carbon atom is chiral, meaning that it's attached to 4 different groups. Now, chirality means that there are 2 different versions of that molecule that can be drawn, and the easiest way to represent those is by imagining that molecule is sat in front of a mirror. And what you can then do is literally draw the mirror image of that structure. And what you will actually be doing is drawing a molecule which on the face of it looks the same. However, if you look more closely at the molecule, you may need to pause the clip at this point to try and visualize that, or even maybe make a little model with blue tack or a pencil or something. But these 2 molecules, although chemically identical, same molecular formula, etc., etc., they're not superimposable. By that, what we mean is it's not possible to rotate this molecule around so that you can make these molecules look the same. So obviously the methyl group in both examples is at the top of the molecule, and what you'll see is that if you rotate the molecule from the bottom, so if you start from the hydroxyl and go essentially in a clockwise direction around the base of the molecule, it's going hydroxyl, hydrogen, nitrile group. If we start at the hydroxide group here and go clockwise around the base of the molecule again, we've got to try and visualize this in 3 dimensions. This is going hydroxyl, this time nitrile, then hydrogen. It's not possible, as I say, to superimpose, to make these 2 molecules look the same without breaking a bond and taking the molecule apart. But those 2 molecules are not identical. Chemically, they are same molecular formula, same chemical reactivity, etc., etc. But these are now chiral molecules. They're now optical isomers, and they will now interact differently with plane polarized light, which is one way of differentiating them. One of them will rotate that light in a clockwise direction. The other one will rotate it in an anti-clockwise direction by the same but equal amounts and opposite amounts. But those 2 molecules are not identical. They can't be sat on top of each other. You can't rotate and twist them around to make them the same. So like I say, it might be worth pausing or something like that if you really try to visualize that. But those 2 molecules are optical isomers of each other, and they're both 2-hydroxy propanitrile molecules. Okay.